All right, guys, I'm back as we're about to begin check your understanding number two, but that's something that I would like to talk about first. Now, if the x-intercepts cannot be identified from the table or graph, okay, they can be determined by solving the related quadratic equation. That is, whatever your quadratic equation is, replace y with 0. All right. In the previous example, in the previous check your understanding, I think you guys were able to figure out what the x-intercepts are by looking at the graph or from the graph, or looking at a table of values where you saw that whenever you had a y value of 0, the x value gives you the x-intercept. All right. The x-intercepts of the graph of a quadratic function are also called the zeros of the function. Therefore, when we talk about the x-intercepts, we are also talking about the zeros of the function. Why is that? Because the x-intercepts actually are defined as those points wherein the y value is 0. All right, that's why it's called the zero of the function. So um, an example would be the one that we just did in check understanding number one, wherein y equals 2x squared plus 4x minus 6 was the graph, or was the function that we did. So to figure out the x-intercept, we just had to make it equal to 0. And then by doing the algebra, we divide everything by 2. All right, leaving us with this. And then factoring out, this is what we have. And we already know that to find the values for x when we have come up with a factored form, each of these factors would be made equal to 0. And therefore, our x would be -3 and 1, which is what we just got from the previous check understanding. All right. I think that makes sense. Let's move on to the next one. So another way to look at the characteristics of a quadratic function is this. All right. It is called the first differences. Okay. So you might want to take a look at the example first in the book. It is really up to you. You may want to do that, but I will also go through this. All right. All it is saying is this. The idea of the first difference is that when you look at the first differences, okay, as you look at the values of the y, all right, if the first difference would be uh, increasing or decreasing by the same number, okay, then it is quadratic. However, if the first difference is constant, or if the first differences are constant, the function is linear. All right, so let's take a look. Okay, so let's say we have this table. So this is on page 274, although the checker understanding for page 274. Okay, so this is um, checker understanding number 2 right here. Okay, I just wasn't able to put it here. The checker understanding was shown to you horizontally. I just rewrote it vertically to make it easier. Okay, so what are we supposed to do here? So let's take a look. The first difference is talk about this. Okay, so let's look at the first difference. First difference. So what we're going to do is we're going to look at the two values here, these two. All right. How do they differ? What's the difference between -1.5 and 2, or 2 and -1.5? All right. So you start with 2, it became -1.5. I think you subtracted 3.5, right? Yeah. What about from -5, oh, -1.5 to -5? Oh, that's -3.5 again. All right. And from -5 to -8.5, -3.5 again. And -8.5 to -12, that's -3.5 again. What does it mean? Since the first differences are the same, All right. They are constant. The first differences are constant. What does it mean? This is not quadratic. This function is linear. All right. This is the first check your understanding. Okay. Now, let's look at what about um, a quadratic. Okay. So we have already seen what a linear one is. So I'll do the second example in the book. All right. This one, table B, is the second check your understanding. All right. But I'm doing the second example instead, okay, which you will see in the book. All right. So this is what I'm going to do. I will again look at the differences. So 1 became -4. I think that's a -5. -4 to -11 is -7. -11 to -20 is -9. -20 to -31 is -11. Oh, what do you notice? All right. The first differences are decreasing by 2. Okay. So it's sort of the second difference. Okay. So some people would say it that way. This one would be -2, -2, -2. All right. So when the second difference is constant, or as the first differences decrease by the same number, the function is quadratic. Okay. The this function is quadratic. Now the first difference decrease by 2, right? So the function is quadratic. This is quadratic. Okay. So let's look at this one, table B. This is letter B on check understanding number 2. All right. So once again, I just rewrote the table vertically because horizontally, I just find it not to my liking. All right. So the first difference, let's look first difference from -3 to 5.5. I think it increased by 8.5, right? What about this one? I think it increased also by 8.5 from here to here. It increased also by 8.5 from here to here. It increased also by 8.5. And what does that tell us? Since the first difference is constant, it is increasing by 8.5. This is linear. Makes sense? Okay. So probably we can go ahead and do check your understanding number 3 to finish this off. Okay. So projectile is launched, all right, upward with a speed of 50 meters per second. Its height, h meters, after t seconds is modeled by the equation. Graph the quadratic function, identify and explain the significance of the intercepts. All right. So I used Desmos to graph the function. All right. It's actually y equals. All right. Now, with Desmos, I replaced the t with an x. It's really the same thing. Now, in the past, some kids would tell me, Mr. Abrin, I'm unable to graph this easily because the numbers that I want to use for the grid, I'm not really sure how to fix that. So take a look at what I have here. On the upper right of the Desmo screen, you should see this. All right. Click on this wrench icon and adjust or play with the X and Y values, and you will see that the grid adjusts itself. It will take some time to be able to really be good about how to adjust the scale. All right, it's always the scale that will be the problem. So it doesn't happen overnight. You need to be playing around with it. All right. So when I graphed it, this is what came out. When you click on the intercepts, all right, at the beginning, it will not show what those values are. But when you click on those intercepts, it will give the values. This one is negative 0.1960. This one is 10.40. This y-intercept is 0.10, and this maximum point is 5.102, 137.551. So let's take a look. All right, let's explain the significance of the intercepts. All right, first, this y-intercept tells you that the projectile was fired from a height of 10 meters, right? Okay. What about this x-intercept, right? So that x-intercept doesn't really make sense in terms of what is happening um, in the situation because we're talking about a real life situation. Oh, sorry. Okay. Oh, sorry. Oops, where did it go? I don't know. So I have to cut this. Okay.